started pretty seriously around late 2010 to do research and development on domestic service robots and the problems that come with domestic environments, which is quite an open board. You cannot trust on anything a lot. The environment is quite difficult, and basically since you are dealing with houses, it means you need to work with things that don't cost a lot. So you want to, at the end, sell things to the households, meaning that you have sensors that are imprecise and actuators that don't work as they should, so you have to basically trust nothing, not even yourself. So, well, the thing that drives us forward was basically the students that come through our education system. So since 2010, we made several prototypes of robots, and well, this is the current team that we have, and the robot there is an old robot. So we are not a technical university, so we are basically working generally on AI. So we weren't really that good with the robot. So as you see, we had several very ugly prototypes in the back, which were not working pretty good. But the latest one was the best, which at least with that one and with a lot of work, we were able to get the 4th place out of 21 teams in the 2013 International RoboCup competition.
Prizes are over there.
Yes, RoboCup competitions in Eindhoven. We also got some other prizes in other competitions, open competitions. But we kept going. We changed our base a bit. We got a bit more sturdier robots, and we went forward. But to be able to keep going, we needed to sort of have a good team. This team comes from good students. So we teach them from a top-down behavior. The bachelor students come to a course and they learn how to do basically behavior programming using these robots, which are pretty easy to use, to follow a ball, kick them, and how to do a very simple football. Then when they start learning how to do these systems, how to deal with failures, then they start working a bit more complex things like modules, face detection, motion recognition. And after they graduate and go to the master levels, we go to even more difficult things like how to detect objects in 3D environments, how to separate sound sources, and stuff like that. In this, yes, so this is a robot, a new robot, working on. We have several sensors. All of them are not very precise. Our arm has around 2 centimeters error on the end effector at the end, and the lasers and the sensor, they also have non-linear errors over the distances that we have to deal. In this demo, what we're trying to show you is first how we work on each module, and then the most important thing is how we can expand this simple demo to whatever we like, but just playing around with the system and building new behaviors and how to deal with failures. So the first part, of the system is our natural language processing, which my colleague Ben both worked on it pretty hard. It means to be able to receive voice commands in a noisy environment. So what happens is when a person talks, our multi-microphone system will detect multiple sources and will try to get the one in a specific angle. Then it will process it into actions and items and location that will make the task that it has to do. Then the system will divide these tasks into multiple states and starts telling each module, okay, now I need you to start moving, to start going forward. So the first thing is usually start moving. We have quite a big robot, so we need to be able to see where we're going. So what we do, as most of the domestic robots do, we have a map of the environment. We can do it either before or online, make a map. And the most important thing is that we have 2 sensors in the front and the back, which allow us to have the 3D information of the robot not hitting anything. So if I walk in front of it, I'll show you the demo that's how it generally works. Then,
still alive.
The next one is to basically object or things recognition. So we want to operate with the board. We need to detect, oh, there's a surface, and then the surface has properties, there are objects on it, and we are slowly trying to build a Borg model of our surrounding environments. We have like table detection, surface detection modules, which usually translate to tables or shelves, and then we have objects which the robot detects and can remember which part of the map it saw it, so next time we want to go there and know where the cup is or where should it put it on. Since last year, we got our first manipulator. Before we were using these arms, which were not well that precise. We worked really hard to get this sort of research arm to work. We are using two systems. One system is a very basic one, which we just command the arm based on what we see. But we have a more complex system which translates what the robot sees into less resolutional blocks, and then the robot will design a path so the arm is sort of safe. So then there comes the part that really helped us in the past years to even do nice things with simple tools, and that's the behavior system that we have. So all these modules will update our knowledge about the world. And with the behaviors, we can easily use these accessibility, so the robot can pick something. You can tell the robot, okay, pick this. Doesn't matter what it is. We want to say, okay, grab an item from a location. It doesn't matter what location it is, as long as our modules are open enough, so they deal with the world in an open manner, we can do it. So in this demo, the idea is that, for example, I give you the command, and I will change the order of the command and change the objects, and we see how the robot will operate. Find the human, get the order, and something can fail, of course, and then we need to be able to deal with these failures, and at least we try for this demo to be able to deal with most of the failures, but the bugs can come up, we never know. Okay. Let's
That's good. Is the behavior already running?
Okay, can you,
switch to Borg.
Yes.
In the meanwhile, you can also see what the robot sees through the. Yes.
afterwards?
Yeah. First, moving forward, the robot has an understanding of where it is, almost in the world, so perfect. So we never rely on that, basically.
So now wait for the speech system to boot up.
What can I do for you?
Might not be ready yet.
No.
Yes.
Okay. Alice, please get the cup from table 1 and empty it in the basket on table 2.
Okay, I will get the cup from table 1. Then I will empty it in the basket on table 2. I am going towards table 1.
As you can see, like in the map, the robot has an understanding of the objects in its surroundings. It's a 3D vision projected to two-dimensional for easier calculations. The robot has a green path, and it will try to follow it toward the goal. And afterwards, since it's not really exact, we think that there's going to be a table in front of us, and the robot will look for one, and let's see whether it can get closer.
Searching for a table to approach.
Probably this table is updated, so there is a new one. And then it needs to be able to, the object to be in its reach, so it plans a path to get closer to the objects. And then
Approaching successful.
now the object
I
detection
found the
module
cup
is
on my
working with
right
the
side.
colors here.
I will try to grasp it.
What's the copper can?
It's set cup.
Okay, so it should grasp the right one. At least attempt to grasp one. In this demo, our manipulation approach is a simple one, because with the more difficult framework, we had an issue with the arm, which we could not control all the velocities of the joints at the same time. So we selected the more simple.
I'm staying close because if the robot should walk into anything, I should press the red button.
I am going towards table 2.
When the behavior grabbing an item was completed and the behavior controller tells the robot, now you go to the second stage of the behavior, which is emptying something and something else. The other one is completely done and the stage is done. One problem with having a differential drive robot is when like car, it needs to like park itself.
Yeah. That's why it takes some time. So who did the programming for that?
But we use open source, some open source libraries, and at this moment, the controller, the driver of the robot is open source, is made for a sort of holonomic robot. That's why it's not that beautiful. Also, you think that the table approach?
Approaching successful.
Successfully. Now next I want to make it fail. So
Really weird. Are you going to push the boundaries?
let's see what happens. That's the important thing when it fails.
So, do I give the next command?
Yes, you can. Like for example, try to take a can and put it on the, bring it to the.
Okay.
Then I go up.
Can I help you with anything else?
Sure. Alice, please get the can from table 1 and bring it to table 2.
Okay, I will get the can from table 1. Then I will bring it to table 2.
This
I
I
am
will
going towards table 1.
try to put the can in a way that it cannot reach it.
You probably shouldn't stand up. It's going to be an object. Find the line.
No, okay.
Searching for a table to approach.
Snapshots. You're not an object. Congratulations.
You can have an object.
Approaching successful. I found the can on my left side. I will try to grasp it.
Not grasp. No, it can't. Doesn't. It tries anyway. Maybe it works.
I couldn't grasp the can. I will try again. Searching for a table to approach. Approaching successful. I found the can on my left side. I will try to grasp it.
There can be multiple failures, but these needs to be like designed before and this found before and implemented in the system so it can deal with it. But if there is a new thing, you can still put it in the system and can cope with it. Let's see with it.
Yeah, so,
I am going towards table 2.
so the important thing is that, of course, if you program all the motions in it, then it would be trivial. But the point is that the library of behaviors, and then you have the sequence, and if there are more complex sequences, then some programming needs to be on everything, because if a family of solutions, but you don't have to do everything from scratch. And there is internal workloads in the
Layer system that you can easily, like for example, now that a lot of effort from the master students was put for the modules to be there, now a bachelor student can sit here and just plan a lot of behaviors with the robot and test whether it works or not. And that's something that we need. Makes us easy to make new things, test new things.
Approaching successful.
Anybody else wants to give you the command? You always, because the thing is, the robot usually likes us and always hears us correctly, so maybe somebody else can try to.
But given time, I think we have to go.
Okay.
Yeah. So thank you very much.